Okay, class, this is one of my favorite experiments to understand why planets stay going around the sun. We know the sun has gravity, the planets have gravity, they're kind of tugging on each other. What happens a lot of times is something passing through space can catch into gravity, and that's how they think many moons came to continue circling around planets. But there has to be the right amount of pull of each, like this, the momentum. We're going to learn in other years at Gray Friars about the laws of motion. But one of the most important laws of motion is that something in motion will continue moving in a straight line unless an outside force acts upon it. And it's going to continue at constant speed. So if something with a certain speed gets tugged on by gravity, it will kind of get hooked, essentially, where it's not being pulled into the planet, or, you know, our planet isn't being pulled into the sun. We're moving at just the right speed with the right amount of mass that we continue just going around it. Much more complicated. There are people much smarter than I that can get into a lot more detail of why it's an elliptical orbit, all that kind of stuff. But for this experiment, I've done this many times. Every time I'm slightly scared, so I'm glad that we're not meeting in person, because I wouldn't want you to get hit with a flying spoon. Moms, if you want to try this at home, I recommend not using twine, because I've found in the past twine can break and then you will have a flying spoon, and everyone has to duck and cover in the nearby area. You're going to take masking tape. The spool of thread, if you use one, you want the biggest that you can get your hands around. You can also try a toilet paper roll, although, you know, an empty one. Tie a normal light kitchen spoon to the other end and have it. Try this again. I erased my last video because it was not proper. We're going to hold the masking tape with one hand, hold the spool with the other, and spin the spoon over our heads. Once it's going fast enough, I can let go of the masking tape. And notice it does drop, but it doesn't drop all the way because the force of the spoon wants to keep going, right? So that is essentially how the forces work, that the spoon and the planets keep wanting to go in their straight line, but then get caught where they're also being pulled in towards the sun, but they don't get sucked in. So, hi kids. So that experiment was a bit tough, but it is one of my favorite ones to see how there are forces in space. Everything is pulling and pushing on each other, and God maintains it, right? Perfectly. Kind of like when we talked about the atmosphere, that technically we have all this weight of atmosphere pushing down on us, but we also have the air inside of us pushing out. That's why we don't go, right? So Mr. Campbell and I tried to figure out a way to make that experiment a little bit more doable at home, if you want to try it. Rather than trying to hold the masking tape in one hand with my pinky, it was much easier holding it with a second hand a little bit below this hand. I certainly prefer something bigger than a spool, but if you start out holding it and have the other one spinning and try to keep it going without the masking tape getting wrapped around your wrist, you can keep it spinning, let go of the masking tape. It will fall a little bit, but it won't fall all the way because of the force of that pull as the spoon is spinning around. So that aspect, as the planets are moving, they're not just getting sucked into the sun, even though the sun is pulling on them. So kind of neat to think of how it goes into orbit. Today we're actually going to get into all the names of the planets. A bunch of you already know these. For my little ones, maybe you older siblings can help your younger siblings. I have a funny thing called a mnemonic. A mnemonic is a big word for letters to help you remember things. My very excited mother. Is your mother excited?
No.
I don't know, after a few days of being at home. Is she excited still? My very excited mother just served us noodles, along with all the other non-perishable food you have at home, right? My very excited mother. Oh, it's backwards on my camera. I'm so sorry. My very excited mother just served us noodles. Does that make sense for anything? No, that is just to help you remember the names of the planets. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So use each of those letters from the mnemonic to help you remember. I like putting everything to a song. You know that, right? So I put it to the Air Force tune of Off We Go into the Wild Blue Yonder. Do you know that song? It's a fun song. So when I say, forgive me, tell me about the planets in our solar system. Mercury, Venus, Earth, and Mars are terrestrial planets. Jupiter, Saturn, Uranus, and Neptune are Jovian or gas planets. Do you think you've got it? So Mercury, Venus, Earth, and Mars are terrestrial planets. There are rocky planets. Think of terrain. Any of you studying Latin? Do you remember that? Terra, T-E-R-R-A, for earth or ground or dirt, right? Terrestrial planets. Jupiter, Saturn, Uranus, and Neptune are Jovian or gas planets. So they're made up of gases. Any of you that get a chance to watch my tour of Squirrel Lake Park, maybe get out and go and do the proportionate solar system yourselves. You can start at the pond at Squirrel Lake Park. And if your sun were there, you walk about 158 feet, and that's where Mercury would be as a little ball. And then you walk to 296 feet, so it's about another 150 feet, and that's where Venus would be, about the size of a marble. And then you walk about another 100 feet, and you're at Earth, which is another marble, and about another 150 feet, and you're at Mars, which would be about the size of a bead again. And then you go, the sizes get much bigger as we pass through the asteroid belt onto Jupiter. That is about, once you get from Saturn, Jupiter is 3 times as far from the sun as Mars is. So from the 4th planet to the first gas planet. And Jupiter and Saturn are mostly made of hydrogen and helium. Holly, do you remember anything that's made from hydrogen and helium? Where have we heard that? There's a big ball of gas burning in the sky during the day. What big ball of gas is burning in the sky during the day? Come on, you know it. It's the sun. Hydrogen and helium. Do you remember? Those are the main gases that make up Jupiter and Saturn. Uranus and Neptune also have hydrogen and helium, but they're considered the ice planets because they also have methane, they have ammonia, some other liquid type things in the planet and the atmosphere. So, you guys, how do we tell our planets apart? If you guys want, go out in your driveway, get some sunshine when the rain finally goes away, and I will send you guys an actual breakdown of how you can measure out a proportionate solar system. Unfortunately, if the sun is 1.4 million kilometers across, or it's 865,000 miles across, Mercury is 36 million miles from the sun, and it's only 3,000 miles across. So to make it proportionate, where you can have something that you can actually see be your planet, you have to go very far. So what I would suggest, if you make Mercury 1 foot away, your furthest planet will be 77 feet away. I'll send you the measurements, but you'll be amazed at how it spreads out. Mercury, as we said, it varies. Remember how we have elliptical orbits? So they aren't perfect circles. And we said how it actually goes slightly at an angle from the other planets. It varies from 29 million miles from the sun, and then at its furthest point of the oval, it's 43 million miles. So the temperature on Mercury varies tremendously depending on how close it is and which side is facing the sun. It goes from negative 280 degrees Fahrenheit to over 800 degrees Fahrenheit. It doesn't have an atmosphere that protects it and keeps the temperature the same. Remember how we talked about how important our atmosphere is? It protects us from radiation and harmful things, rocks flying through space. Our atmosphere is one of God's protective things that He uses to sustain life. We have the perfect atmosphere to keep our temperature on Earth perfectly controlled for human life. Kind of amazing. Mercury doesn't have it. Another thing, it doesn't have anything to burn up all of the meteors and asteroids that pass through space. There's always rocks and dust traveling around in space. And usually when it hits the atmosphere, all those layers of air, those molecules literally cause such friction that it breaks the asteroids apart. And once it enters the atmosphere, it's called a meteor. We'll learn about that in a few weeks. Mercury doesn't have that. The moon doesn't have it. That's why they're covered with craters. We're going to study craters more too, but they're super cool. That's what makes it look bumpy. Can I show you a picture of Mercury? Let me see if I can find it. Moms, one thing, when you go to find books about the solar system, you have to be careful with the date first, because stuff changes as we discover stuff. This book is from the early 2000s. 20-year-old information is not always helpful. But check out this picture of Mercury's surface. Isn't that cool? So our next planet out is Venus. Venus, on the other hand, has a tremendous atmosphere. It has so much carbon dioxide that all the heat from the sun gets trapped. It's over 800 degrees on the surface of Venus. Can life live there? No way. No way. Venus has this tremendous atmosphere and tremendous storms. Volcanoes that spew this carbon dioxide gas create the greenhouse effect. Remember the idea of our solar ovens? How you can make s'mores by trapping the sun's heat? You'd have some pretty awesome s'mores on Venus, huh? So Venus is, let's see, what else do we want to know about it? It's the one that comes closest to the Earth out of all the planets because the way its orbit is, it comes as close as 26 million miles from the Earth, okay? A lot of times Venus is the most obvious planet in the sky. You can see it super clearly. A lot of times this time of year in the western sky right after sunset. So go out around 6 p.m. and there will be a really bright star. It looks like a star. It's actually a planet. Without even trying, you don't have to be an astronomer. And you'll say, Mom, is that Venus? And then your mom can pull out her cell phone, pull up her Skyview app, aim it at it, and sure enough, find out that it is Venus. Moms, check it out. If you have a chance, there's a free version of Skyview, and you can take it out, identify the constellations just by aiming your phone at them, okay? And the planets, it will tell you where everything is and the things that are on the other side of space. Next up, at 93 million miles from the sun, what planet is it, Holly? Where do we live?
Earth!
Earth! Yes, it's our planet, our perfectly designed planet that God made at 23.5 degrees with the perfect atmosphere to sustain life. Perfect amount of water. How much water covers the Earth? How much of the Earth's surface? 75%.
75%
of the Earth's surface is covered by water, right? God perfectly made our Earth to sustain life. Our surface temperature goes from negative 129 degrees Fahrenheit and as high as 136, which doesn't seem ideal, but that's certainly a much smaller fluctuation than what we see on other planets. Mr. Campbell has had to sleep outside in negative 28 degree temperatures.
Cold.
Thankfully, never negative 129, but he can tell you it was cold. He also, in the military, you get to experience some strange things in the military. He's also had to live in 132 degree temperatures in Djibouti, Africa. That's pretty hot. He said he would finish his entire water bottle while at the water fountain and then refill it because he got so hot. Okay, let's continue our journey. After Earth, what's our last terrestrial planet? Our fourth planet. So, my very excited mother, M for Mars, the red planet. Mars is smaller than Earth. Its orbit takes about 2 of our years, okay? It's 35 million miles on average from Earth, 142 million miles from the sun. Its day is about 24 hours, about the same as ours, right? The temperature varies from negative 184 degrees Fahrenheit to 63 degrees Fahrenheit. Its highest temperature is pretty chilly. It's like a March day. That again has to do with the gases that are trapped in its atmosphere, right? It has 2 moons that they think were captured asteroids that were passing by and got caught up by its gravity. One thing that makes Mars unique is it has huge volcanoes, some as high as 20 miles tall. Whoa, buddy. It also has really deep canyons and valleys. Its deepest one is over 4 miles deep. Do you remember how far we've been able to go below the Earth's surface? Not very far. The Grand Canyon is amazing.
And it's so cool.
It is only 1 mile down. Mars has canyons that go 4 miles down. Pretty amazing. After that, we pass through the asteroid belt. So the way that our solar system is laid out, and I'm hoping that I can draw it in a way that isn't too backwards for you guys, is we have Mercury, Venus, Earth, and Mars are all really close to the sun. Okay? There's Mercury, Venus, Earth, and Mars. So our first 4. Then we have the asteroid belt. Lots and lots of rocks. Jupiter's orbit is 3 times as far as Mars. Then when we get to our next planet, Saturn, it is 1.5 times. No, it's 1.8 times. So almost 2 times as far as Jupiter. Suddenly I'm almost off my board, and we are just on our 6th planet. Okay. Then Uranus is about 1.5 times as far out as Saturn, and Neptune is almost 2 times as far out as that. So notice how quickly it expands. After Neptune, we go almost another 2 billion miles, 200 billion. What is it? Another 2 billion miles. And that's where Pluto would be. And then we have what's called the Kuiper Belt. That's another area. Tons of stuff floating out there. That is where they believe that there are 4 additional planet-type things. And beyond that, there may be more. There's, I think it's called Sedna, and I'm going to look it up really quickly so that I don't mess it up. Sedna and what's the last one? Xena. And there may be others. We're discovering stuff every day, right, you guys? Maybe one of you will become a scientist and go and work for, or be an aerospace engineer. Go work with NASA. And maybe you'll discover something great someday. That would be amazing. I hope you share it with me if you do. Okay? These gas planets are huge. Jupiter is 80 times. Let me see, double check this. So Jupiter is 1/10 the diameter of the sun. It's 30 times as big as our smallest planet. It's about 15 to 20 times the diameter of Earth. So Jupiter is huge. One thing that's interesting, though, is the bigger the planets don't necessarily have that much more mass. Saturn is huge as well, but it's, I think, 90 times the mass of Earth. So it's depending on the density of what they're made out of. All of these outer planets also have something cool. They have rings. The one that's most known for its rings are Saturn, but all of those outer planets have rings. Another very cool thing with Jupiter, Saturn, Uranus, and Neptune. Get this. When you start out, so Mercury, it takes 1/5 of a year for it to make it around the sun. It takes 58 days for Mercury to make one rotation. A day on Mercury is 58 Earth days. It rotates super slowly as it's orbiting, right? Venus, it rotates even more slowly. A day on Venus is 243 Earth days. It takes just over half a year for Venus to orbit the sun. And so it takes longer for a day on Venus for it to rotate than it takes for it to entirely orbit the sun. On Earth, our day is 24 hours, obviously, our night and day rotation. And it takes 365 days to go around the sun. Mars, about the same rate of rotation, and it takes about 1.8 years, Earth years, for it to orbit the sun. Jupiter's day, here we have this massive, gigantic planet. it takes 9 hours for it to rotate. So it's spinning around its axis really quickly. It takes about 12 years for it to orbit the sun. Saturn, it takes 11 hours for it to rotate. It rotates around its axis really quickly. 29 years for it to orbit the sun. Uranus, 84 years for it to orbit the sun. Its day, 17 hours. So you guys, it's interesting. You could do the math. If you want to go and get a calculator and just practice your math skills, I'll send this information to you. Which planets do you think are traveling the fastest through space? Does it have to do with their density? Does it have to do with their mass, their size, the length of the orbit, how close they are to the sun? I don't know. These are great questions to explore, though. Neptune, its day is 16 hours. So all of these gigantic planets have a tremendously fast rate of rotation. Get this, a year on Neptune, so one orbit around the sun, takes 165 Earth years. Pluto takes 280 years to orbit the sun. And remember that the IUA, determined that Pluto does not count as a planet because it does not clear its neighbor. It crosses paths with Neptune. I'll show you a picture of how this orbit looks. Okay, so Neptune's orbit, all of the other planets are blue, and then Pluto crosses for a 20-year period, about every 200 years, it crosses Neptune's orbit. And that's why they decided to not count it as a planet. Others have not counted it as a planet because it doesn't have dominance compared to other objects in the Kuiper Belt. But from 1979 to 1999, Pluto was actually inside of Neptune. Kind of cool. 200 years from now, that should happen again, but I don't think we'll be around to see it. What do you think? So, you guys, the things that define each of our planets, I want each of you to, I'm going to show you really quickly. I'm going to leave the screen for just a moment to show you a thing that I made with Holly. We made a model of the solar system on a paint stick. It's a measuring stick. So we use stickers of the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Obviously, we couldn't make it perfectly proportionate. And then what we do is you take clothespins and you tape facts about each planet to connect it, okay? And you match up the facts with each of the planets. So I want you to research. You can make notes about the atmosphere. You can make notes about the size of the planet, its mass, its average distance from the sun, its geology. What kind of rocks and gases do we find there? Its surface features. Are there lots of volcanoes or crevices, craters, canyons, valleys, whatever? What is the temperature range there? How many moons does it have? What's your general impression? With Uranus, I think blue ice planet that rotates on its side. With Jupiter, I think gigantic planet with a sunspot and many, many moons. Saturn, the rings. That's what I think of with Saturn. Venus, I think of hot, crazy atmosphere that traps heat. So you can try to make something yourself. Just labeling, you can do it with paper, you can do it with anything, and play a matching game. Help you remember the different planets. Is it super important to remember all the details about a planet? No, if you become an English teacher, you may never need to know all of the details of the planets. But it is quite impressive when you study them, that God made them because he loves creating. He created some amazing things. And today you may want to be an English teacher, but maybe 20 years from now, you'll decide, wow, I think I want to be an astrophysicist. And then suddenly you'll be really glad that you memorized this stuff right now. The possibilities are endless. Each of the planets has tons of things that you can research. I encourage you. I personally love this magazine. It's called Stardate. I'm sorry that it appears backwards on the phone. This is from the McDonald Observatory in Texas. You can find them at stardate.org. Parents, be careful because obviously dates and how the world was formed in a lot of these will not have a biblical perspective. And that's why I really push for Christians to go into these things, know what we believe and why we believe it and how it fits together, right? Stardate.org has tons of information. NASA has an entire kids club section. They also have a section where they've partnered with the University of Arizona where you can collect rocks, mail them to NASA to help them build up a sample of what types of rocks make up our Earth and how does that compare to other planets. Research some of the missions that we've had. What missions do we have nowadays? Where's the funding coming from? There are governments that partner together. There are international organizations. And now more and more there are private organizations. SpaceX, fabulous work recently. They're launching stuff every day. Last week they launched, I think, 60 satellites into orbit. If you have a chance, look into Kennedy Space Center. I'm sure that they're offering online stuff now while everyone's stuck indoors. The museum in Huntsville, Alabama. There's also a great space museum in Colorado Springs, Colorado, through the Smithsonian, the Air and Space Museum. Check these out online while they're probably offering some research online that you wouldn't normally be able to get. And maybe if everything returns to normal soon, you can look into if this is something that really interests you. There's Space Camp. It's a great opportunity to study science and have fun at the same time. My nephews did that last year and loved it. And I'm going to send all of this information. Hey, babe. She helped me do our solar system walk. And I'm going to send you some numbers so that you can do your own solar system walk either in your driveway or you can go and check it out at Squirrel Lake Park. I miss you guys, and I hope you're having a great time at home. Help your mom, and I'll look forward to seeing you soon.